Hello and hi, friends. My name is Jérôme Labon. I'm the CTO of the open source project Uno platform, and I'm live streaming generally on the every Tuesday at 3 p.m. Eastern Time, US. And I'm generally discussing things about Uno platform, live coding, answering questions, and talking about topics around what we've been doing in the Uno platform. And this week, I'm going to be talking about two things. The first one is the support for memory profiling in WebAssembly applications. So .NET memory profiling, and that's something that's very new in the Uno platform. And the second part is taking a look at what Preview 3 has been causing, Visual Studio Preview 3 has been causing trouble in Uno. So we're going to be trying to troubleshoot that. And I've been told by Matthew Lebowitz from Microsoft that Uno is doing something evil and that it shouldn't be doing it. So we're going to be taking a look at what's not supposed to be there. I see Johnny and and Lamwalker too are both here. Happy New Year, and thanks for joining. It's been a while. The UnoConf has been very intense, and lots of new things that have been released. And it took a while to get to a stable pace after the conference. So we're at that point, and many new things that we're going to be announcing. We've been working very hard on performance, and hence the updates with the support for memory profiling. So let's jump into it right away. So developing .NET applications and applications in general, if you don't have tooling and you're pretty much stuck. And that's where we were when debugging an application for a client, and we weren't able to determine where the memory was going when developing that application and troubleshooting. So we know that the Xamarin Xamarin targets in general do have support for memory profiling, and it's done through what is called the log profiler. So this is added through the support of the memory log profiler. There are two tools that allow for getting this and analyzing the content. The first one is the Xamarin Profiler. The Xamarin Profiler is a tool that's deployed as part of Visual Studio, and we can actually take a look at that. I don't know if there's a screenshot of this. There it is. That's the memory. That's the profiler. So we're going to take a look at what that does in a moment once we've gotten to run it. And the interesting thing is that because Xamarin applications are using the mono runtime, and that WebAssembly is also using the mono runtime, so it's now called the mono VM. That means that we can get to a point where we can get the logging profiler, which basically logs everything that happens inside of the runtime and plays that into MLPD files. So we're going to take a look at those, and we can get that integration. What we needed to do is to take that log profiler and enable it to run within WebAssembly application. So by default, the runtime doesn't compile it. .NET 6 doesn't do that. And we had to make a small modification to the .NET runtime, so .NET 6, so that the log profiler is built and can be used from an Uno enabled application. So when we're saying Uno application, we're talking about a Uno Wasm Bootstrap enabled application. So not necessarily an application that uses the full Uno WinUI part and WinRT part, but if you're making a small application using just the console and you want to troubleshoot the performance there, that you can do as well. So let's jump into this. We're going to make a small application. So I'm going to be using Visual Studio 2019 for today, or at least for that part, because I installed, let's say violently, or foolishly, the version of Visual Studio Preview 3 so that we can troubleshoot it later on during the stream. But building an application for Uno with Preview 3 doesn't work. So let's jump to 2019 for now so that we can get something running pretty quickly. So I'm going to create a small application. Let's call it Wasm Memory Profiling 2, because I created one just to show that it actually works before, so that you don't get stuck with me just fiddling around with it. And we're going to be updating the UWP the WebAssembly application the part of the application to the latest updates of the bootstrapper. So I'm going to be updating everything Uno for that one so that we can get to the latest. But basically, the bootstrapper 3.2.0 dev something has support for the memory profiling. So I'm going to be updating all those, and then we're going to be building the application and trying to profile the application and see what happens there. Okay, so let's build this. So there's one thing to do to enable the profiler because it's not there by default. We need to go and take a look at the documentation for the bootstrapper. So the first thing that needs to be done is to add this property to the application so that the profiler is linked into the runtime. By default, it's not there because it changes the runtime significantly. So we don't want to have all this causing trouble with the runtime itself and performance impact. So we basically recompile one part of the runtime that enables the logging profiler. So let's take this and put it in the debug section. It also should work with in release mode as well as AOT mode, but we're going to be discussing that one a bit after so that you can see exactly what that means when you're enabling AOT and try to profile. So let's compile and see what we can see here. So when we're enabling that part, that means that we need to have one additional part that's linked into the profile into the runtime. So what that means is that it needs to link a part of a C object file. So it's an object file compared from a C file that comes from the runtime. It needs mscripton to build it. So that's why the build is a bit longer because it's not like when you're debugging an application using the interpreter and you can just take the runtime that comes from .NET and then run it as is. So it takes a few seconds. So now it takes a bit more time because it needs to link everything up. And gives you access to everything that is needed for the runtime to compile. So we can actually take a look at a few files that are added so that you can it demystifies a little bit of what's happening. But in the work AOT folder, there's a new file somewhere in there that is called, I think if I remember correctly, profile something. Oh, it was generated afterwards. Let me see. There's driver gen. I don't know if it's there. Let's see. Takes a while to do this. Driver. So there's the driver there. Oh, there's a packager. It takes a bit of time. So there's all this. So that's not that. Core bindings. Okay, so let's see if it's there. We're going to take a look afterwards. Okay, so the application started up, and once we want to, the profiler starts right away, and then we want to take a look at analyzing what the application is doing. So this application doesn't do anything; it's just showing up hello world. There won't be much to profile, but then we're going to take a look at what that means. So there are two hotkeys that can be used. The first one is Shift-Alt-H for memory snapshots, and Shift-Alt-P to save the profile. So what we're doing here, so let's just take a profile first and let's open it. So what you see here is a new profile file that's been created by the application running. And when I hit Alt-Shift-P, it created the file from the recording of everything that happened in the application from the beginning of the application running. So if I open this in the Xamarin Profiler, I can select allocations. We can be discussing the time profiler afterwards, but there's a bit of things there that's not needed. So let's do start profiling. Then it's a small file. I don't recall exactly by how much it is small, but it should be pretty small. Okay, 4 megabytes. So it's pretty small. And for now, because the application is doing nothing, when the application is going to start doing a lot more, then it's going to be quite larger, and we can get files to a gigabyte or 2 gigabyte depending on what you're doing. So there it is. That's the application running there, and you can see all the allocations that have been done. And for instance, we can take a look at, for instance, why do we have we have that many binary readers that are there? So there are two things that you can do. The first one is go to the call tree. So there may be things that need to be adjusted from the Xamarin side, the .NET side actually. So because when you do drill down here, well, that's the first part. The first part is you can get access to all the instances that have been created or that are still live. And let's take a look at see if there are some that are live. It doesn't look like there are. Oh, on that view we can't see that. So we're going to take a look at the snapshots. The snapshots give a way to know if the instances are live or not. So let's go back to allocations, and let's create a snapshot actually. So let's go back to the application. We're going to make a snapshot again, and then create another profile. So the application continued running, the profiler continued running, and then I can do additional things in between. Then we can open the profile again. So I'm going to close the other one, and we're going to get a snapshot. So we get there's a new tab that's there. It's called snapshots, and I can see what's been new since the previous snapshot. So this one, there was nothing, but if we make a few of those, we're going to get those. So now I can see, let's say we were taking a look at one specifically. Let's look at the retain size, for instance. So we can see, for instance, that there are, let's take one, setters. So there are 164 setters that are live, and we may want to know where those come from. So now we can find which instances are still alive and what's keeping those in memory. So let's take a look. Hi, Mark. Thanks for joining. So we have a set of dictionaries here. So we can see that those setters, for that specific setter that has been created at the timestamp 2 seconds, it's actually held by likely a control or the application. So it's probably top level resource dictionary that's held by app.xaml, for instance. The other interesting thing is that you can know when that allocation has been done. So if you look at the stack trace, you can see that that specific allocation for a setter has been done during global static resource initialization. So we can see here that it's done because of the fact that the application was started up and the global dictionaries were there. So were initialized. So that's where we get to it. We can also see that none of them have been collected. So that means that all those setters are present as part of styles that have been declared in the application for a lot of reasons. It may be for a good reason, may not be for a good reason. So that's the kind of things that we can do now when analyzing applications running with WebAssembly. So now let's go and analyze that a little bit more. Let's say we create a leak. So if we go in the application, and we're gonna be just clicking stuff up and making a leak, and actually, let's make two things. We're gonna create a leak and resolve the leak. So let's do this. We're gonna make 2 buttons. Oh, Visual Studio 2019. There you go. Okay, so we got content, we got allocate. Allocate. Let's do the same thing with the other one. Clear. And we're going to take a look at this. Okay. Allocate. Yeah, I'm definitely missing 2022 there. It's definitely working better. Okay, allocate. And we have unclear. So we're going to make a small list. Just going to allocate a large chunk of stuff. Let's call that memory. And when we press the button, we're going to be adding stuff in the gonna make new byte arrays of a bit of memory, and then cleaning it up when we're done. And we're going to be calling jc.collect as well, so that it actually clears up the whole thing. So there we go. So let's rebuild this. So one of the things that's interesting and that we found out while developing that part is that the WebAssembly runtime, the .NET runtime, and the way it's configured is that you can only go up to 2 gigabytes of RAM, or actually 2 gigabytes of addressable memory. And there's a way to change that in Emscripten so that you can go to 4 gigabytes of memory until the WebAssembly specification goes to WASM 64 that will allow to go way past that. But the interesting part is that the .NET runtime has not been developed with the 4 gigabyte switch in mind. So it goes by default to 4 gigs to 2 gigs, and then if you enable the 4 gig switches, and it's something that it's enabled, that's discussed here. 4 gigabyte. So if you enable this, then it'll mostly work. But then when it reaches 2 gigabytes and more, then there may be some function in the .NET runtime this time that may not be aware of that change and will fail with weird errors, errors about memory overflow and things like that. So that's the kind of things that needs to be addressed, and we're probably going to be opening an issue in the .NET runtime so that it can be changed. So you would say, why do you need that much memory? Well, there are people that do need that much memory in running their app for good or bad reasons, but that can happen. So let's do some allocations. I'm going to make a heap shot, allocate again, do another heap shot, and then I'm going to clear everything, do another heap shot, and then generate the profile. So it's pretty quick. And that's pretty good. You can profile for a while. Just know that the profile file is stored in memory, in the JavaScript side of the memory. So the longer your profile runs, the bigger your Chrome instance or whichever browser you're going to use is going to get bigger. So that's one thing that you need to know. And there's no way for now to stop the profiler. So if you keep your tab open and your application's doing a lot of stuff, then it will eventually blow up your system's memory. So just so you know. Hello, Alfredo, thanks for joining. So let's open up that profile and see what this one shows up. Okay, so we can see that we've allocated a lot of bytes. So over the course of the application, we allocated 320 megabytes of system bytes, and at the end, there isn't any. So that means that our leak is actually gone. Hello, Angelo. Thanks for joining. I see Brazil is in force here. So that's that. So that's the system bytes that have been collected. So let's take a look at the snapshots. So now we can see that the first snapshot we had 122 megabytes more, then 200 megabytes more, and then at the end, because we cleaned up, then 320 megabytes less. So that's why we can see that the memory actually got reclaimed. So that's good. So if we go to the snapshot, we can see that in the retained size, we have likely somewhere bytes array that should be here. Yeah, there it is, system bytes. Well, it shows it at the end, so it's the retained size is removed because it's done it at the end. But let's take a look here. So it's not live at the end, so it won't show it. Well, a little bit. And so those ones are not the ones that I want to take a look at because they've been created by the resource manager. So that's not particularly useful. Let's see. So that's one of the few things that need to be taken into account when profiling. Some of the traces may not be correct. I'm not sure exactly why. I don't know if it's because WebAssembly is recording method names in a certain way and they're not showing up. They're not showing up properly in a stack trace. That may be one thing. So just so you know, it may be something that may be of interest when taking a look at this. So maybe let's take a look at another another snapshot. Maybe if I take a look at the first one. No, it's so live at the end doesn't say anything, so it doesn't say. Yeah, the browser socket. This is something else. Okay, so it doesn't show it. We probably need to allocate something. Let's do some allocation, then take a snapshot again. Let's take a heap shot, then a snapshot. Oh no, not that one. Okay, heap shot, snapshot. And let's open it again and see if we have stack traces available. So snapshot again. And if I take a look at this here, do we have, yes, we do have some that are live, and then the stack trace still not available. So in some cases, for some reason, I'm not sure, the traces are not set properly. So Tutis is saying, I think retained size is memory of referenced object that will also be freed when you free current objects, since this are bytes buffer and not hold on to other objects themselves. Well, they're actually held to something. So let's take a look at this one. You know, it's held by the generic list, and you can see that it's held by main page, which is held by a few other things, and you can see that it's held by a grid and probably a page. So it's held by something, but it's not there in the list in the previous snapshot because those objects were freed at the end of the trace. So maybe it's not tracking everything up. So I don't know. So there are a few things that need to be taken a look at and analyzed, but there are a few other things here that tell you what's being held. Like for instance, is the hot reload agent that's used for Xamarin hot reload. They're held by static fields. We get a few things here with GC handles and threads. So lots of good information that need to be that can be analyzed there to say, you know, Uno, you're doing some crappy stuff and you need to fix your memory leaks. That can be, or it will allow you to get your application in shape and you know, chase all the event handlers that you're not unhooking from everything that's coming from Uno or everything else. So just so you know, so that's the one way to debug to profile your WebAssembly applications using the Xamarin Profiler. So that concludes the first part of the first part of this stream. Let's take a look at what's happening with building application using Visual Studio 2022 and why you know, things are not working well. So we're talking about Visual Studio 2022 17.1 Preview 3. And there's something that has been fixed by the Roslyn team. And it looks like it's broken something that we're doing in Uno, intentionally or not. And we're going to try to figure that one out. So a lot of people have been hitting that issue recently, and people that have been coming up to take a look at to discuss that with us on Discord. And we haven't had a good answer to provide as of yet. So let's take a look right now. So we're gonna be trying. Let's try with the GTK one. That's the easiest one because it's gonna build the fastest, and see what kind of errors we're gonna get. Okay, so we're using Roslyn, and it fails because it says this file, Uno Analyzers, is a binary file instead of a text file. So one of the reasons that may happen is that we're adding files, actually we're adding those files to the set of files that need to be taken into account when building the application. Now, the interesting part is, why are we doing this? So let's take a look at why we're getting those files and why we're getting that error. So let's build again and take a look at some build logging here. So if you don't know about this one, very important, I'm taking the time every time I'm discussing this one. And if you're new to that stream, the build logging is particularly important when you want to troubleshoot building applications and when there are errors that you don't know about, like why do I get that error before? So this one actually failed because it didn't rebuild completely. So let's do a full rebuild so that we get the actual error coming up. Okay. So to install that one, those tools, you can go to extensions. You search for Project System Tools 2022, and you're gonna get that build logging window that you can add. It's available here in other windows, build logging, and will give you that specific window that you can open then afterwards using the binary MS Build Structure Log Viewer. It will give you a lot of information here to know what's happening. So you can see here that we get the log for the compiler itself and see why we're getting that specific error. So those files are coming from actual analyzers. The Uno analyzer is that one, but there's also the Uno UI source generator, and both are passed as parameters to the compiler, but in a way that it doesn't like. So let's see. So the analyzer is supposed to be passed first as this, but there's also another one, which is called additional files. And in additional files, we're also providing those DLLs and analyzers as part of this. So the reason we're using this is inside of a source generator or an analyzer, you can get access to files that are part of the compilation, but without having to read the file system directly. And it's something that's very important because it's and I'm taking this from the .NET. So I'm paraphrasing, but taking this from the compiler team, but they want to have reproducibility of builds. So to be deterministic, then the idea is that you need to be able to capture the content of the file and then do something about it afterwards, but from what the compiler has captured and not everything else. And for some reason, they changed the fact that if you add binary files to that list of files, then it will fail. So now we have to find out why this happens and see if there's a good reason for those files to be in additional files. And I'm not entirely sure why. So let's try to find out where that is included. So I know by heart, but I want to show you why, where that actually comes from. So let's go and copy this. I'm not sure if it's going to copy the content. Yeah, that's the right one. So let's do this and try to find app insights there. So we can see here that there's a target that manipulates additional files, and that's the only one, which adds that DLL specifically at that location. So what I want to know is, why are we adding those files? And it's likely this line, because we're not doing anything else afterwards. So it would be, so analyzers, additional files cleanup. Okay, so that would be additional files. Looks like we're doing some fancy cleaning here, but it's likely to be this one. So we're getting to additional files cleanup. That's interesting because it's not, okay, it's that one. Okay, so we're adding files in the additional files group. Then we're doing something to remove the files that have been added, probably for duplicates or something like that. I learned recently that there's a property that you can set on a property group to remove the duplicate files. So we're going to be taking a look at that. So let's go take a look at that line and see why why are we adding those lines. Maybe there's a good reason, maybe there isn't, but let's see in the, if we can blame someone, probably me, and see if we have something that we can change there. Okay, so inject additional files, and it looks like it was changed a long time ago. And it was about adding support for C#9 source generators. So it doesn't look like there's a good reason for it. You know, at least it doesn't say in the logs. So we're going to drop that line. Plain and simple. There's probably not good reasons. So there's source item group here. I'm not sure if we're doing this. So we're going to be taking a look at it. So the first thing that we can do is go and let's go and update to the latest version of Uno. And we're going to be altering the files directly in the NuGet cache. So let's update to the latest, and we're going to be manipulating those files directly. There it is. So the version that I've installed is for 7.1. So let's go in the NuGet folder, and we're going to be manipulating that file. Nope, not that one. So we got uno.ui, and it's this one, and that file is here. It's this one. So we can probably find the additional files here that we're adding that would not supposed to be there. Let's see. It's called inject additional files. There it is. So if I drop that line and rebuild, does it work? And it looks better. Okay, so that's better. Now we're gonna have to dig into what why the additional files were there. It could have been because of, you know, trying to get something with determining kind of an up-to-date check, maybe. You know, could have been something like that. So determining if the compiler needs to make sure that something has changed. So when we're changing, let's say when you're inside of Uno. So let's open the Uno solution, because we're gonna have to dig into this one. Let's go to Uno. There it is. So let's open. So we have the override here that's set to net standard 2. So we're going to be opening the, let's go open the Skia one. So we open the solution filter so that we don't have the whole set of targets that are supported by Uno. They're loaded up in Visual Studio. Even though Visual Studio now supports it somehow properly, it's still very, very memory intense or intensive when loading everything up. So you still want to have the filters on. So so the idea, I think, behind that inclusion of the analyzers in the list was probably to have some kind of an up-to-date check. So when you're inside of the Uno solution, the analyzers are actually changing, because when you rebuild that specific project, which contains all the generators that are part of Uno, then the file changes. So we wanted to be able to make sure that the compiler would detect that changes are made, and then it would rebuild everything, maybe. So to know if we're actually using those, there's a way to determine that, and there's an API for this. So that property is actually interesting. So this is something that allows for a specific API in the analyzers to get access to something that's coming from MS Build, because by default, generators actually the C# compiler doesn't know about MS-Build. It gets past everything that's needed to compile what you've been given, what you're giving it to it, what you are giving it to. You know, so let's take a look. The compiler is called this way, and the whole things that are used by the compiler are provided as parameters, but the compiler cannot know about things that are coming from MS-Build unless it's provided in a specific way. And there's one thing that's done by the compiler to actually hack that through and still provide a way to get access to what MS-Build is providing, and it's through the analyzer files. And there's a interesting thing that has been done. I would say, you know, interesting for now, and it's a file that contains properties and item groups that are from the MS-Build context, and they're placed in that editor config file. So if we take a look at that file in the application that we just built, that file is going to be here. There it is. There it is. So there's that file, and the MS-Build tooling is generating that file and taking everything that is coming from MS-Build that has been marked as MS-Build, and as should be known by the source generators, and placing those into that file. So let's say, for instance, you have source item group analyzer here, or let's take application definition, for instance. So if you search for application definition, it says that that file is coming from this path, this identity, and is a link to its link name is app.xaml. Now there are many others, like well, in that context there are not many, but you know, let's say if you have resw files or things, resw files are there. So you have PRI resources, but you have many others that can be placed there, and those ones are giving a way for the source generators to get access to those properties that it wouldn't get access to any other way. So now if we take a look at one generator, so let's say, I think it's this one, the entry point, and never remember this generator, XAML generator, there it is. So that's the entry point, and we're going to go into XAML generator context. So in here, we get access to things like get MS-Build items, and that is actually poking into, so we get this is the generator execution context, and then it gets into MS-Build items, and get MS-Build items is poking into that file to get all the files that are marked as source item group page or application definition or what else. And what we need to find is, do we have an MS-Build items that doesn't use page, but that uses analyzers instead? So let's browse all the get MS-Build items to see if we're actually using that in any meaningful way. And so far, it doesn't look like it. We have custom UI automation member. We have PRI resources for resw files. We have the application definition, so that's your app.xaml, all the pages. So pages meaning all the XAML files that are not app.xaml.cs. We have a binding generation here. We have this one, which I don't know what that is. I build search path. We got here project references, app definitions, and pages. So that's that one. That's one that's used when we're generating the resources, generating the hard reload configuration. So we can probably go take a look at that one if it's generated properly. Doesn't look like it was this time. Let's see if we rebuild. Does it show up? So it's supposed to show up here, but it doesn't look like it wants to. Let's see. Let's see. I haven't had much success with those items for some reason. Sometimes they show up, sometimes they don't. So we'll see here. Let's see. Analyzer. Oh, they do this time. Okay, so probably a first load issue, maybe. I haven't reported this. Maybe if someone from the .NET team watches this, maybe it'll give you some hints. So the remote control generator is actually using this to get what's needed to access the files back, and it's not generating the file. Let's see if I rebuild. Maybe I'm gonna get access to it if we're lucky. Rebuild worked, but it doesn't give anything. No, doesn't want to. So one thing that we can do, and that's something that Uno uses for itself in some cases, and also for Xamarin applications. There's a configuration that allows to go back to non-Roslyn hosted generators, and that is something that you can find in the file here. And there's that property. Uno UI uses use Roslyn source generators, and if you copy that to your application and rebuild, it's going to disable the use for Roslyn hosted generators, and you will get access to the files on disk, not through Visual Studio. So I know that I've discussed that with the compiler team, and they cringe when they hear this because of reproducibility and determinism and things like that. But it's very useful to debug. So in the ops folder, you get a G folder, and then you get to remote control generator. And then here in that file, you get access to things that were passed from MSBuild to the compiler through generators. Then in the generators are written into attributes. So we can see here that we get the CS proj, you get the files, you get all sorts of things that are very interesting. And all that is given back to the application, the running application, so that it can now be read from the hot reload system. So kind of convoluted, but that's the idea. So all in all, it looks like that line that we were looking at before, which is here. Let me take that back again. So it would be here. Delimit, no, sorry, content here. So that line is probably useless and something that was not supposed to be there originally, but because it wasn't failing, then it kept working. So probably going to make a patch for that in at the back part to Uno 4, so that it continues working properly, and probably Uno 3, because if people want to upgrade to a later version of Uno, they may have some issues with Visual Studio 17.1 as a result. So there it is. So we're going to make a PR out of this later today, so that it'll fix everything up. Jose Silva says, can we compile an Uno platform desktop app using ahead of time? So desktop app, do you want to use the let's say the Skia GTK or Skia WPF? Is that what you want to target? Because if that's the case, there are two ways for doing this. The first one is to use ready to run. So ready to run is something that .NET has been providing for a while now. That has improved significantly since .NET 6. So yeah, .NET 6 ready to run, and there. So that's the ready to run compilation. So that one is going to be basically you pass that property here, and it will pre-compile the application for your target. So specifically that one, or Linux, or let's say you want Linux or Mac OS. Then you get a runtime identifier specific compilation for your project. It'll build specific binaries for your target, and then it will get it will get to your application being ready to run. I know that for .NET 7, the .NET team is going to get to something newer, and that one is called, if I remember correctly, I think it's native AOT or something like that. So native AOT. Yeah, native AOT. So if you want to follow that one, I'm not sure exactly how far that one will go, but it'll likely be pretty deep. It looks like it was, if some of you are still remembering Core RT, that's one of the things that will be happening there. Probably a newer version of this, but it's pretty hard to get something that works properly with those, especially if you want to do pure AOT without any compilation or I'm sorry, no jitting or no interpreter. That gets very difficult depending on the target. So you know, the mono team with iOS, you learned that the hard way, especially when they had to do because you can't do any jitting on a you can do any jitting on iOS, so that's where they had issues there. So anyways, so that's the two things that you can do, but native AOT is probably going to be only .NET 7. So the one thing that you can do is use ready to run compilation. So search for ready to run, and you're gonna get in shape. Another question. Which way do you recommend to use internationalization in Uno platform apps? Well, in the same way you would do in a WinUI application. So let's say WinUI app. I would say this. Probably localize your WinUI 3 app, and it's gonna be pretty much the same thing. So there's some parts that are not related, but the rest is going to be everything related to localizing WinUI 2. So let's take like a UWP for now. I think we're gonna get that one. Localize UWP. Localizing your app. I would have thought localize string and localization Windows Universal Apps. So that's the kind of things you can take a look. And we also have documentation on Uno specifically. You go to our docs, there's localize. To localize text resources, you get a step-by-step that shows you how to do it. So with localization here, you get the xname, xuid, and then everything that goes along with the manipulation of the resw file, and all of this. If you want more information about MVUX, that would be questions that you can ask directly in our Discord channel. There are people that are going to be talking about this, and there's David from our team that will definitely help you there if you wanna dive into it more deeply. So that's that. So that's it. So now we're going to take a look at one thing, and that's preview 3 again. And I'm pretty sure that that's something that's probably going to fail afterwards, but let's take a look anyways. Looks like there's one Visual Studio that's done for some reason. Let's see. Yeah, it looks like it's broken somehow. Okay. So let's look at our application. And so the .NET needs to be updated when running with a more recent version of Uno, of Visual Studio. And one thing that may happen is that Visual Studio won't be able to compile your application using Preview 3 because there are breaking changes that have been integrated into application for .NET 6. Actually, we need to create a new .NET 6 application. And you're very welcome, Jose, I would guess. If you have any other questions, just drop us a note on the Discord. We'll be happy to discuss all this. So let's build a .NET 6 application and see. Pre3 .NET 6 app. Let's see how much it breaks. Because I know that some breaking changes have been introduced by the .NET team, and there's likely some things that are not working properly. So let's figure how much of it is breaking. So if we go to, well, actually, let's try with Android first. So mobile, I don't know. It doesn't look like it's. So we're missing a few things here. So let's see if we unload the project and reload it. Does it work better? So I know that the startup needs to be made and the package needs to be restored for that to work properly. So let's see if that has changed somehow. And it looks like it has. So that would mean that the application doesn't, so that would mean that Uno is not setting the right properties for everything to work properly. So the .NET team is integrating a few things, into the configuration file so that it enables or lights up features in Visual Studio, and for some reason it broke there. Jose, if you want to go to our platform Uno, I think we have support here, and in support, I think we do have we have Discord. So you have GitHub here, and you have Discord here. You can join the conversation here. So happy to discuss. Okay, so it doesn't work. So let's see if it builds. So I'm trying with Android first. So let's see. Okay, so first thing first, it breaks using this. So that means that the runtime that's being used to build the application is not the right one. So we're going to try something first to see if we can actually revert back the application to something that that was there. So let's see. That was there and that can be used. So we don't have a global .json, so let's add one. So I never remember the format for this one. I don't know if you do, but I never do. So let's take a look. In Uno, I do have a file there at the root somewhere that has the right format. There it is. So we had global JSON.NET 6. There I go. Okay, that's the good one. So we're going to add that file at the top and set it to the right content. So it's going to be global.json. And we're going to be using the right version of the SDK. So no rolling forward. That's the first one. And nice one, Johnny. Okay, I'll remember that one. Didn't know about this one. It's going to be useful for sure. Okay. So let's see. I do have installed. So we have 6.2, that one. So you got this one that's installed. I don't know which one we need to use. Okay, so to figure which one we need to use, we're going to go to Uno check. Oop. Missing an H. And we're going to take a look at the different files that are there, especially the manifest here. So that one would have been for the preview 11, so the previous one, and it works on 6.000. So that would mean neither of those, which are not installed. So I'm going to be installing Uno check so that it installs the right one. And we're going to be doing this. So install. Oh, it's already installed. So let's do the update then. It's going to be installing 102. Uno check. So let's see. That's another thing that I wanted to try. So if Visual Studio 2022 Preview 3 is installed, and we can see it here, what should it do? So we can see that the only version that I have is Preview 3, though this one is using Preview. This version of UnoCheck is using Preview 2. Well, we're still gonna do it. So let's install the SDKs and the workloads specifically for 601 to see if that works properly. So there's some failures here. Okay, so it doesn't work. It does not work at all. So that means that we have another. So it may be looking like we're using a specific version of the file that tries to download something different. So for some reason it's using 60200 and we wanted to have 60100. And that's not the one we want. So of course it fails because it's not the right one. Okay. That's a problem. So that means that if you have Preview 3 installed, then UnoCheck won't work at all. So we're gonna have to change that somehow. We can probably try and get a specific manifest to see if that helps somehow. So let's take a direct link to the manifest. See if that changes something. Okay, tries to fix. Does it get to another version? No, still doesn't work. Okay. So I wonder if that's related to this or there's something else. So one thing that we can go take a look at is the package still available somehow? Because maybe it's not using the right one or it's trying to update. So one thing that we can go get to is go to that feed and oh, not that one, because that one doesn't support this. So that was the online version of it, but that's not the one I want to get to. So let's take a look at this one. So we need to get to a specific package. So it tries to download. It tries to download something here with a manifest, with another type of manifest that we're not getting. So maybe it's something different. So from rollback file here, that's pretty deep. That's pretty deep. It looks like there's a manifest somewhere and we're not getting the right one. And it looks like it's not giving us the right thing. So for some reason, it's downloading something completely out of place. And it should be downloading another version, but it's not. So probably going to have to troubleshoot that somehow. It's likely to be something in there, in that file, but I don't know what that is. Okay, so lessons learned. Well, actually, lessons learned, or something to know. If you're installing previews, you're gonna get in trouble, and that's what we get. That's what we're getting into at this point. I'm probably gonna have to ask the .NET team where that comes from and why we can't get the previous versions installed as a result. It may be something that has to do with the way the workloads are identified, or maybe versions that are not the right ones or something like that. But I don't know what that is, so we're gonna have to investigate. Still, the good thing is that if you're not doing some .NET 6 development, it is still going to work because you're going to be able to install, you're going to be able to build your application and not have the weird error with the analyzers not working. So that's one of the good things that we're going to be able to push in the next few days. So that's it. that was an interesting one, and you starting again after that long of time with the pause of the holidays and things like that. So I hope you had some fun, and if you have questions, just join us on Discord. And until then, see you next week. Bye for now.